All right, guys. Here's kind of the plan for you guys for this week and next week. Okay, just so you can kind of see what's going on. I only have you guys for 2 more weeks. That's really sad. Yeah, I won't miss you either, Justin. All right, so the goal, though, kind of like these next 2 weeks, what we're looking at. This week, we're going to look at just a couple sections out of Chapter 5 on buying and selling a car, just because that's a very real-world thing that we need to look at. Today's lesson on it actually kind of just goes back to, you can see the learning targets as mean, median, mode, range, quartiles, interquartile range, stuff like that. A lot of that is probably very much a refresher for you guys. I haven't decided yet if I'll do like a little mini quiz on Friday over it, or if I'll just kind of incorporate it into the exam, or kind of where I'm going with that. We'll kind of see where we're at, so depending on what we do. But then next week, your exam is actually going to be in 2 parts. So those of you that are still taking the exam, I'll give you guys the review over part 1. I'll probably just give you time to work on it in class on Monday. Then we'll go over it Tuesday. We'll take part 1 on Wednesday. We'll work on part 2 on Thursday, take part 2 on Friday. That way I'm kind of split it into 2 parts where you're only kind of focusing on 1 part at a time, not everything for the class, because we've done a lot this year. Yeah. I haven't finished writing it yet. I just haven't had a chance to work on it much. I don't know. I probably won't put any multiple choice on it. You don't want my multiple choice.
No. Her multiple choice.
Or a lot of times I'm like, I know they'll do this part wrong, so I'll do it that way, and then I'll put that as an answer. You know what I mean? It's awful. It's awful, yeah. Jessica? Yes. Yep, guys, just like in the past, those of you who've had me, I will give you a note card that you can write anything on it that you want, okay? Usually you get whatever note card I find in the cupboard. If the giant ones are in there, that's what you get. If the small ones are in there, that's what you get. You're like, forget that. Noah?
So, are we last year you let us use her note card and formula sheet?
Yes, like you guys have like the red formula sheet and stuff. Yeah, you would be able to use those. I wouldn't make you rewrite that on it.
Can we type up
No.
formula sheet?
Nope. 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 You can use your formula sheets that I've given you that I've let you use in the past, okay? And you can use a note card that you can handwrite. And you're not splitting it in half. Yes, you can do front and back. All right, let's go ahead and get into the section for today. Oh, Tyler? Nice, what'd you get? Like a brand new, brand new? Aren't you all fancy? Nice. He's an only child. You're an only child? Did you buy it or did your parents buy it? But like you're paying for? Awesome, good for you. Is that your key you're flipping around your finger right now? Probably don't want to let that out of your sight, do you? Oh, it's a stick? Why did you buy a stick if you can't drive a stick? Well, no, I will say they're fun to drive. I used to have a stick shift Camaro.
Some people cannot drive without
Shut up.
Some people cannot drive stick because
Anyone can learn. Anyone can learn.
has a stick shift and she doesn't go stop.
Okay, well,
She needs to learn. Yeah, it's not that hard. You just need to practice. She just needs practice. All right. Guys, let's go ahead and get through this so I can give you time to work on the assignment tonight. You know, I'd hate to make you take stuff home if you don't have to, okay? All right. So 2 websites that are very helpful for you guys when you are looking to buy a car. I don't know how familiar you guys are, but yeah, it's Kelley Blue Book, it's kbb.com, or Edmunds. Those are the 2 very helpful websites. KBB, Kelley Blue Book, that's a great one to figure out like the value of your car. I know, like, if I'm going to sell my vehicle, I check the value on here. If I'm going to buy things, I check the values of them. You know, like, I don't want to pay more than I have to. If it's not worth that much, then I don't want to pay that much. No?
How much does your piece of yellow, or how much does the tiger feel?
How? That's very subject. I'm actually going to have that up for sale pretty soon. I'm going to sell it.
How much?
I haven't decided yet. If you just go by strictly like a 2002 Volkswagen Beetle, they're not worth a whole lot.
I
But
got $100 in my wallet right now, babe. Down payment.
no. But honestly, it's kind of subject because my car it's rare because of the color concept package that's on it. So I can't look mine up on Kelly Blue Look.
It's not rare. I saw another one.
There's 2,000 in the world that look like mine. No.
Alright, so here's what you have to do. All you do is put it up for like 10 grand and then let them talk you down to like 8.
If I could get like 7 or even if I could get like 7 for it, I'd be happy.
See, that's still put it up for 10.
So put it up.
See, some people wouldn't. Some people would.
Let them talk you down.
Right.
Coolest owner.
Yes.
If I set this at $2,000 towards something, would you be interested in trading it?
Well, I will trade you my 1990.
No, my husband is selling his truck, and I'm going to sell my Bug, and we're going to buy him a nicer truck.
How much is this truck?
I think he's asked 6,500. I think
What year is it?
it's a 2002 Chevy Silverado 2500 HD. That's what he has. So. No, he really wants the matching vehicle to our Arcadia. He wants the GMC Sierra 2500 Denali. That's what he wants. That's what he wants. All right. Also, you guys have heard of Carfax? You guys heard of that? Carfax report's going to let you know if it's ever been damaged before, if it's ever been in an accident. You know, you can figure out who's owned it in the past. You know, sometimes it's nice to know, like, why have like 17 people owned this vehicle in the past? You know, it's kind of, yeah. See, that's things. Yeah, those are things like you want to know before you buy a car, right? You want to know if it's been damaged. All right, so before we get into data though with cars, let's look at some previous stuff. Isn't he cute? Whoa. Let's look at some previous stuff that I'm sure you've learned at some point or another. The measures of central tendency. Do you guys know what they are? Yes, you do. Yeah, the mean, the median, and the mode. You guys have seen those words before, right? Mean, median, and mode. Those are called your measures of central tendency. Why do we use them? You learned them back in probably junior high, but why? What's the point? One of us finding the average, yeah. But we use it to kind of summarize data, a set of data. Now, one thing that I always think about is like anytime you see like numbers and data like in the news, my brain automatically is always going towards how did they skew that data? Because I can get the data to say whatever I want it to say by using whichever one of these I prefer. Because, you know, depending on your numbers, the mean or the average can vary greatly from the median, the middle number, and versus the mode, the one that shows up the most often, right? But if I want the data to say one thing, I might use the mean. But if I want to say something else, I might use the mode. So anytime you see numbers like in the newspapers, on the news, things like that, be thinking about where are they really pulling the numbers from. They could be skewing the data just by using a specific one, okay? All right, so all three measures of central tendency are averages of a sense, okay? We must always look at the data and decide which measure actually fits the best. So the measures of central tendency that best describes a data set may depend on whether the data has an outlier. What's an outlier? Good, it doesn't really fit. So it's one that's either much greater or much less than the other values. Yes. Yes. My Bug price listed would be an outlier. Yeah. Did I skip a slide? No. That's all right. Sorry, sometimes it does jump, so it's okay. So outlier, a data value that is much greater or less than the other values. When you're looking at them, you're like, whoa, that one kind of sticks out, doesn't really fit. And we're actually going to look at an outlier, like how to actually calculate whether or not it's an outlier. Like, according to your opinion, it's an outlier. According to his opinion, you're like, nah, it's not really that far out of the realm. So there actually is a mathematical way to tell if it's considered an outlier or not. Because you know, if you're looking at like car prices, they could all be ranging somewhere in this range, and then one might be way over here. But is it far enough over here to be considered an outlier or not? What do you mean 10 numbers?
Sir, punch holes wall.
Right. Noah?
I just want to say this. Out of only 2,000 being around,
I was still stuck in the car.
He's still stuck in the car.
Still stuck in the car.
What about out of 2,000 what?
there's 2 million.
That's bad luck on my part. I'm sure mine's better though. Mine has less than 100,000 miles on it still.
Yours is a lot brighter too.
That means then it's not the same. Because there's orange, there's sundown orange, and then there's snap orange. Mine is snap orange. There's 2 different colors. We're talking about my car again. He keeps bringing up my car. All right, here we go. Here's the mean that Marissa thought I missed. The sum of all the data values divided by the total number of data values. Or in other words, add them all up, divided by how many there are. You can write whichever one you prefer. Add them all up, divide by how many there are. That to me is how I always remembered it. Who needs a fancy way to say it when you can just say it like that? Oh, did you guys want the fancy one? I'm sorry. All right, guys, the mean or the average, this is one that you want to use to describe the middle of a set of data that does not have an outlier. So maybe highlight that in your notes, star it, circle it, something so you see that, so it can help you remember which one should you use when. Okay, so the mean is used when there is not an outlier. They all seem to be kind of in the right area. Nothing's crazy big or crazy small. Okay, so highlight that, star it, whatever. All right, the median, what's that? That's the middle number. So you can summarize. You don't have to write word for word, guys. The middle value, just write middle number. When values are arranged in order from least to greatest, they have to be in order. For a set containing an even number of data values, when you kind of go to find the middle and there's 2 in the middle, what do you do with those? Add them, divide them by 2. Yeah. So if there's 2 of them in the middle, you got to add them up, divide by 2. You're averaging the 2 middle ones then. Sometimes it's easy to tell if one of them's 100 and the next one is like 120. What's in between 100 and 120? Be 110. Some of them's easy to see it. Your chair's hitting the desk as you are spinning. All right, so median, middle number, make sure in the order from least to greatest. And then use the median, that jumped. Use the median to describe the middle set of a data that does have an outlier. Okay, so use median when it does have an outlier. That's a good one to use. Okay, middle number, least to greatest. There's 2 in the middle, add them, divided by 2. Use this when it has an outlier. Moving on. You guys should know this by now anyway, right? And then there's mode. What's mode? Most often. Yep. The data item that occurs most. A data set can have no mode. When does it have no mode?
When there's no number that occurs most often.
Good. Like if every number is listed once, there's no mode. One mode, so one number shows up more often. Or there could be more than one. So let's say the number 7 shows up 3 times, the number 8 shows up 3 times, the number 100 shows up 3 times, right? Right, since they're all showed up the same, like then that can work. Use the mode when the data is non-numeric. What the heck does non-numeric mean? Nope. What's numeric mean? Number. What does non mean? Not. It is not a number. Those are numbers. Letters. Objects. Not numbers. They're not whole numbers, but they're still numbers. Or when choosing the most popular item. You know, what's the most popular beverage? Pepsi, Mountain Dew, water, milk. You know, I'm not asking you to tell me what your favorite is. That was not the point of that.
But you got different answers in water also.
Chocolate milk, sour milk, whole milk, skim milk,
Sorry,
almond milk.
Almond milk is good. So can
You know what's gross? Skim milk.
That's delicious.
That's gross.
I know, you like to chew your whole milk over there. We've discussed this.
So good.
All right, here we go. Let's actually do some math now. Find the value of x such that the data set had the given mean. So if I want a mean or an average of 51, what does x have to be in order to make that have an average of 51? Good. So we would add them all together. So 55 plus 60 plus 35 plus 90 plus x, right, divided by 5, and it should equal 51. So you know me, I'm an algebraic person. I would write it up as an algebra problem.
Yeah, initiate difficult start. I got 48.
So 55 plus 60 plus 35 plus 90 is 240. Try it again. All right. Okay. Whoa, 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 whoa. And wrong. Stop. Because, guys, the numbers you added up, you only added 4 numbers. No, no, no. To find the average, you would add all of them, including the unknown, and divide by 5, right? Because there's 5 of them. I need to solve this equation. I can't just divide here.
So you need to take 5 and times it by 51.
Yes.
And divide it or whatever.
Yeah. We're going to multiply 5 times 51. It's kind of like cross multiplying. I hope so. That hurts. So we cross multiply. And this is 240 plus x. And then to figure it out, yeah, just subtract 240. Probably not, because cross multiplying is a skill that you should have learned in, like, I don't know, 7th grade.
Yeah, that was the last question.
Yeah, I think of teachers.
Guys, take it down a notch. You guys are out of control today. Now, I'm an algebra-based person. I would do that algebraically. Now, if you are not an algebra brain person, you could guess and check. It would take a while, but you could get there eventually. All right, so guys, for me, I would set it up algebraically because that makes the most sense to me. So again, you have 5 numbers, including your unknown. So to find the average, you'd add them all up, divide by 5. So I just kind of cleaned up the top. I cannot divide this, okay, because this whole piece is up on top. So this is kind of like over 1. So you're cross multiplying. So 51 times 5 is where the 255 came from. This times 1 is just going to kind of come down here. And then to get x by itself, we just subtract the 240. Now again, you can always check this, plug this back in up here, and actually see if the average does give you 51. And it does. Okay. Yeah. No. That's going to average the 4 of them. It's not going to take into consideration that I want to add another number in, because then that's going to change your average again. Nope. Sorry. I'm glad you're trying to think outside the box, but yeah, it doesn't work. Okay. Other questions on this problem? This is probably the hardest algebraic one we're going to look at. All right. So next slide. Example 1. Jason wants to sell his Ford SUV. He compiles these prices from the internet for cars similar to his. So there's all the prices. What is a reasonable price for him to consider for his SUV? So reasonable price. Should he look at the mean, the median, or the mode? Now, keep in mind, one of them is used when there is an outlier. One of them is used when there is not an outlier. Do any of these look like outliers? 12,000 is close to 11,000. So this is why Cole's 10 rule
Is it?
does not apply.
It's in thousands, so it's more than 10,000.
That's a terrible rule.
Boom.
That's a terrible rule.
Law of cold.
It's
Sir,
9,000.
Catello's law.
I think that's
All right, guys, there does not appear to be an outlier, so the mean would be your best option. Okay, so we need to add them all up. I'll write them, you add them, okay? All right, so when you add up all the top numbers, what did we get? What? When you added up the top, did you? Josh? Thank you. I can't hear when you guys all talk at once. And then divide by 5, and what'd you get? But do we see why it makes sense to use the mean? None of them seem crazy big or crazy small. All right, example 2. Dory is looking for a classic 1967 Firebird. She finds these prices on the internet: $18,000, $77,000, $22,000, $21,000, $19,000, $17,000, $22,000. She computes the mean as $28,171.43. This number doesn't seem to be a good representative of the data. How can she find a better representation? There's an outlier. All right, so there is an outlier. So how do you think she computed the mean? So what should she have used? Thank you. Somebody pays attention. She should have used the median. Okay. She should have used the median. Okay. Now, did this question actually ask you to find the median? All right. Did you guys figure out what the median was? What do you have to do before you can find the median? You have to put them in order. Okay, so if I put them in order, the cheapest one, 17,500, and then 18,000. Yep, 21,200. Lot. Oh, yep. 22, and then 22.5. Yeah, do you use the 28? That's the mean. We don't use that one. Oh, yeah, and there's the 77. I totally didn't see I had that one on there. Okay. Now, why did I cross them off as I did that? Yeah, so you don't write the same number down twice, especially when you got a long list of them. And then to find the median, I always kind of just start on the ends, and you cross them off, right? So the one in the middle, 21,200. Okay, and that does seem like a much better fit for the price of the car than the 28. Because that eliminated that 77,000 as an outlier. I just kind of took that off the list. All right, example 3. Find the median of the following used car prices. So again, median, you have to put them in order from least to greatest. Okay, so let's do that first. Noah, honey, hold on. Give everybody a chance. All right, in order from least to greatest. And then to find the median, just kind of cross them off until you get to the center. That's what I always do. So there's 2 in the middle. What do you do when you have two of them in the middle?
Add them together, divide by 2.
Add them together, divide by 2. Yeah, so for medians, when you have two that fall in the middle, you add them together, divide by 2, and in this case it is 77.50. Now, you may have been able to just look at that and know that, and that's okay. All right, guys, so example 4. Prices found online for the same GPS navigation system are $295, $345, $199, $225, and $200. Find the range of the GPS prices. Nice. Very good. So, guys, range is the highest number and then subtract the lowest number. So, in this case, Jessica, the highest number was $345 minus the lowest price for it, $199. So $146 range. So that means the prices range by that much of a spread. So does it pay off for you guys to do a little research before you would buy one of these? Yeah, you could save $146 depending on where you're buying it at. Okay? So that to me sounds like something you definitely want to research to find the best price on. A GPS? It's going to be very outdated. Noah?
Martin, it's like GPS included, you know, like with OnStar and stuff. With that whole.
If you pay for OnStar.
No, like just stock, isn't it included?
Yes. Like my vehicle has GPS like built into it, but I'll tell you it's not the most accurate. I use my phone. It's much better. All right. Guys, the next part of this, oh my goodness. All right, guys, let's actually finish learning all of this before we get interrupted again. All right, guys, box and whisker plots. Do you guys remember these at all? I'll be honest with you guys, when I was in school, I never learned how to do these. And then at one point when I was teaching in Finley, I was teaching like a beginner algebra class, and these things showed up, and I'm like, what the heck is that? I'd never seen them before. We're going to look at today, like, we're going to stop speaking. Everyone needs to just stop speaking. We're going to look at parts of the box and whisker plot today and, like, looking at different pieces of it, but we're not going to be drawing any of them today. Okay? That's tomorrow. Okay. Well, good. Then I'll just teach it for, like, if you've never learned it before. They're not hard. Box and whisker plots, they're broken into quartiles. When you think of a quartile, what do you think of? 4 corners, quarter, a fourth of it. We're taking the data and breaking it into 4 sections that each section represents 25% of the data. That's what they're doing. So you can kind of analyze different sections of the data a little better. That's why they do it. So make sure, again, your data is listed least to greatest, because the median, that middle number, we're using that process a lot. So first, when you look at the minimum, it's just your lowest data value. I assume you guys could have figured that one out. Minimum is the lowest data. Lower quartile, or Q1 as they call it, is the median of the lower half of the data. And I'll show you, like, the way this works, like, you find the median, the one in the middle, and then you find the median of the numbers on this side, and you find the median of the numbers on this side. It's really not complicated. It is not hard. Median is the number in the middle. Now, the median, you know, make sure we make a note, median is referred to as Q2, or quartile 2. And you want to find this first. Oh, man, that looked terrible. Find first. All right. And then the upper quartile, or Q3, is the median of the upper half. So again, find the middle number, then find the middle of what's over here, find the middle of what's over here. And then the maximum That's just the greatest data value. And the maximum number is referred to as Q4. So you want to know where that fourth one is, it's right there. It's not called anything. I agree, it is stupid. Why they have to label some of these things, I don't know. That's just what they call it. All the minimums are what? Q sub 0? That's what we're talking about. It does not have a name. Just minimum. Minimum sounds nice. All right, and then we have the interquartile range. And this is a lot of times abbreviated IQR, because, you know, we're lazy mathematicians. But your interquartile range, it's just Q3 minus Q1. You're just subtracting them. Yeah, all this sounds like crazy, fancy, hard stuff. It's really not, okay? I don't want you to panic over this. It's not that hard. A lot of putting things in order from least to greatest is what you're doing. All right. Let's actually try some. All right, so again, up here just kind of talks again about that it's dividing it into 4 subsets. Each of them takes 25%. That's why they're called quartiles. Quarter, it's a fourth of it. Q3 minus Q1. All right, find the quartiles for the tire pressures of cars at an auto clinic. All right, so the tire pressure is measured in PSI for pounds per square inch, in case you did not know that. So it's like 15 pounds per square inch, 17, 21, so on and so forth. All right, now what do you notice about the data that's up there? It's in order, which is nice. It's already in order for you. So it wants us to find the quartiles. So Q1, Q2, Q3, Q4. Which one did I tell you to find first? Q2. That's one you find first. All right, so to find it first, we need to just kind of check them off, find the one that's in the middle. So 31. All right, maybe make yourself a note so you don't forget that is the median. Okay, and then to find Q, you could go Q1 or Q3, it does not matter. Q1 is just the median of what's on the front half of this. So if I go to cancel these off, I end up with 2 of them in the middle. Again, Q1 is just looking at this, what's on to the left of the actual median. All right, so how would I find the median between 17 and 21? Add them up, divide by 2. So 17 plus 21 divided by 2 is 19. And then Q3 is the median of the back half. I hope you could look at 32 and 32 and know that 32 is in the middle, right? I know, hurting your brain on a Monday. And then what's Q4? That would be 34. That's just the maximum. Huh?
So say you want, like, say you're trying to find it, but I don't. So say you took 15, 17, put them together, 21, 25 together, 34, 52 together, 36, and then 30 together.
Hey Noah, can we get a question like this underneath that? No other way.
Don't think so much. All right, example 6. What is the difference between Q1 and Q3 from the data set from that last example? So again, it's asking for the interquartile range of the IQR, which is Q3 minus Q1. So Q3 was 32, right? And we subtract Q1, which Q1 was 19. Right? That is 13. Now, a couple things to kind of keep in mind the range in the middle numbers, we're looking at like the 50% of it, right? From Q1 to Q3 is like 50% of it, or it's looking for that. That's what this number is representing. If you have a small IQR, that means the middle numbers are clustered together. Middle numbers are clustered together. And if you have a large interquartile range, IQR, the middle numbers are spread out. And you know, some people make big money to look at data and analyze it and look at all these numbers and how the trends are and how things are going, and people get paid big money to analyze data like this. I couldn't give you an average, but when you're good at math, like my brother always told me that I wasted my talents as a teacher because I'm good at math. He's like, you could have made so much more money doing something else. He wanted me to be an engineer. I have no desire to be an engineer, not a train engineer. Because I'm good at math, which I could have, but no. They do. But they work year round. I do not. You betcha. I have a family. I like having time off. Money's not everything. Oh, sorry, hon. All right, and the next thing we're going to look at then is actually finding the outliers. Like what technically classifies it as an outlier, and not Sir Cutchell's rule over there.
I think Sir Cutchell's rule is great. I'm gonna write it up on a piece of paper and I'm gonna change it somewhere.
Hannah, are you done writing, hon? Okay. All right. So here we go. So reminder, the outliers are the ones that are much more or much less. But how much more, how much less does it actually have to be? Okay. So again, highlight this, circle it, star it, whatever. So something that on a note card for the exam, this would be something I would write on it. You know, make sure you want that. All right. So to find out the lower outliers, this is a formula here, guys. You would take your Q1 value and subtract 1.5 times the interquartile range. And then for the upper, Q3 plus 1.5 times the upper interquartile range. So really, we're just finding a lot of numbers and plugging them into formulas. That's all we're doing here. Okay? So let's actually try some of this. So find the outliers for these tire prices. So what do you have to do with the tire prices first? Make sure they're in what type of order? From least to greatest. Are these in order? Yes. It's nice when they're actually in order. I think that's the worst, when you go to rewrite them and you wrote them all out and you're like, oh, I missed one. You have to like go back and like try to write it in. It drives me crazy. Oh no, they'll be out of order. You're welcome. All right, so finding the outliers. Now, when you look at this, does your gut instinct tell you that something is amiss? The 545? What do you think? Do you think the 45 is an outlier? Your 10 rule will tell me that's an outlier. See if your rule applies. See if it works. All right, so to find your lower outliers, we would have to take Q1. Do we know what Q1 is? No, we got to find all this stuff. All right, so before I actually do all of this, let's do a little bit other stuff. Let's actually find our quartiles. Q1, Q2. Do I need to find Q4? Is Q4 being used in anything? No, let's forget about Q4. All right, so which one do I find first? Good, the Q2. So we're going to go ahead and cross things off to find. Hey guys, Cole's making up math and we all know it. Let's just do the actual math that works. All right, so my Q2 is 146. All right, so to find Q1, I have to do the median of the first set. So here we cross off, and then I'd have 2 here. So what do I do with the 2 of them? Add them up, divide them by 2. 88 plus 109, and divide by 2. And what do we get? 98 and a half. So 98.50 if we're talking money here. All right, and then Q3, that's your median of the back half. So again, you're going to end up with 2 in the middle. So 202 plus 218 divided by 2 is 210. All right, so I had to actually find some data before I could actually answer the question of what are the lower outliers. So the lower outlier formula then that we just looked at was Q1 minus 1.5 times interquartile range. So what else do I actually have to find? The interquartile range. Remember, that is just Q3 minus Q1. So I'm going to take 210 minus 98.50. Yep. All right, guys, so what is the interquartile range? 111.5? Or 111.50, because remember these are all dollar values. All right, so we're going to take Q1, which was 98.50, minus 1.5 times the interquartile range, which was 111.50. And what do we get? Right, so what that number means, because you're like, what the heck is that? So to figure out the lower outliers, the number that you get, anything less than that number is an outlier. So do we have any lower outliers? No, I do not. Okay. Now your whole rule of 10 though?
Cole, all the numbers are more than 10 away. So would it apply?
No, you're not getting what he's saying. What he said.
Let's not base all this on Cole's made up math though. Okay.
Yeah, the pulling over.
All right, your upper outlier. There's the formula, Q3 plus 1.5 times the IQR. So my Q3 was 210 plus 1.5 times the 111.50. And what about the upper outliers? So again, on this one, it's telling you since this is the value we got, then anything greater than this is an outlier. All right, so lower outliers, did we have anything less than negative 68.75? No, so there were no lower outliers. Okay, what about the upper? Anything greater than 377.25? Yeah, you had that 545 on there.
He's got those strong margins.
Okay, So that's an outlier. So guys, the bottom line, what we're looking at is I need to make sure you understand where the formulas come in and how they're used. Okay, you're plugging numbers in. Lower, anything lower than that number. The upper, anything higher than that number. I think it sounds pretty self-explanatory in those. How are we feeling? Great. It's a little tedious, yeah. But I mean, it's fine in medians, and I mean, the math part of it's not that bad. Last question. Each year, the 880 seniors in North Shore High School vote for one of the 110 teachers to receive the annual yearbook dedication. The teacher who receives the most votes, or the mode, right? The teacher's name is written down the most. See where they're tying this in? They win. Can a teacher who receives only 9 votes win if every senior votes? Very good. Well, that's only the seniors. But still, yes. Good to remember that's an entire high school. This is just the seniors, though. All right, but back to what Josh said, because he's absolutely right. But if you divide 880 divided by 110, that means there's 8, right? It's a 1 to 8 ratio between teacher and student. So if everybody voted for somebody different or whatever, it's possible every teacher could have 8 votes, except how could one get 9? Right, instead of voting whatever, like one teacher only got 7 votes, so that one got 9. So could they? Yes. Yes, he could win. Okay. That'd be like a pretty well liked staff, I would think. That's kind of spread pretty thin if that really actually happened. I don't think that would happen. I think if seniors here voted for their favorite teachers, I don't think you'd see like 8 votes, 8 votes, 8 votes for like every teacher. I think you'd see like, you know, like favorite teachers kind of popping out amongst them.